I'm going to be covering lesson 61. It is review. It's information that was covered in Algebra 2, but I will go through each piece. You could also do today's on the calculator. So 61 has a lot in it, and it's all review of statistics. So in 61.A goes over single variable analysis. So if you're using your calculator, you would have to enter your data and select single variable or single variance in order for the calculator to do this. But I'll show you how to do everything by hand. So let's go over a few things. The mean, I'm sure you guys remember how to do the mean. The mean is simply the average. And it's really important you can recognize this symbol because that represents mean. Next is our range. That is the difference between the max and minimum data point, so the largest minus the smallest number. Then there is variance. And variance looks at the average of the squares of the deviation from the mean. And last is standard deviation. Its symbol looks like a theta and then x. And this evaluates how spread out the data is. So it's the average distance from the mean. It's also the square root of whatever you got for variance. So if you find the variance by hand, standard deviation is simply the square root of that number. Now you can use Desmos to find almost all of this, so if that's what you're using, that's totally fine. But I'll show you how to do it by hand. So example number 1, if our data is 4, 7, 9, and 20. So let's go over how to find the mean, our range, our variance, and our standard deviation. All right, so mean, right? You're simply going to add them up and divide by how many there are. So if you add them up, you get 40, and there are 4 pieces of data, so our mean is 10. Range is the largest number, or your maximum, minus the smallest number, or your minimum. And so my range is 16. Variance. So variance, you're going to take each data point and subtract the mean. So it should look like x minus the mean squared plus the next data point minus your mean squared, and so forth. So this is for variance. It's also in the book. So my next data point is 7. So 7 minus the mean squared plus the next data point minus your mean squared plus the next data point minus your mean squared divided by the formula is over the number, the amount of data you have. So I'm going to simplify this. Right, 4 minus 10 is 6. 6 squared is 36. 7 minus 10 is 3. 3 squared is 9. 9. The difference between 9 and 10 is 1, so that's 1. That's 100, and I'm dividing by 4, and I got 36.5. So that's the variance. For standard deviation, I'm simply going to take the square root of whatever we got for variance. And so my standard deviation is approximately, I should put a little approximately because we're rounding 6.04. Okay, so that is it by hand. I'm going to do one more with you, and then we'll move on to 61.B. And it's really just to give you practice if you're following along. So here is our data. So 12, 7, 15, and 10. So again, I gave you a really small list. So let's start with our mean, or x with the line above it. If you add them all up, I got 25 now. I got, I think I did this wrong. Hold on. 12 plus 7 plus 25. Whoops. Well, let me turn my calculator on. So that's 19 plus 25. 44 divided by 4, so I got 11. The range would be 15 minus 7, which in this case is 8. The variance, so that would be 12 minus my mean squared, plus 7 minus the mean squared, plus 15 minus 11 squared, plus 10 minus 11 squared. And there are 4 pieces of data. And so that gives me 12 minus 11 is 1, 1 squared is 1. Plus 7 minus 11 is -4, -4 squared is 16. That again is another 16, and that again is 1 over 4. That gives me 34 divided by 4, which I got is 8.5. Which means my standard deviation is the square root of 8.5, which is approximately 2.92. Okay, so that should cover that, and we are going to move on to 61.B. Now, a lot of 61.B can be found in your book, but I will just, and again, this is review from Algebra 2, but I will quickly go over a normal distribution. Also known as our bell curve. So a normal bell curve, it looks like an old school bell. I don't know why they call it that actually. And it looks like this. And it kind of models like grades in a class. Few people have A's, B's, C's, D's, F, if this was to represent grades, right? Most people fall in between in the middle. So I'm going to go over how you would set this up. Right through the middle should be your mean. And so then this lower half is 50% of the data, and this upper half is 50% of the data. Now, using the standard deviation, I'm going to break it up into 3 sections on each side. So 1, 2, 3, 1, 2. So this is plus 1 standard deviation. So it would be the mean plus 1 standard deviation. This would be plus 2 standard deviation plus 3. If I'm going to the left, you would subtract 1 standard deviation, subtract 2 standard deviation, minus 3. From here to here represents 68% of your data. So 68% of the data falls in between a plus or minus 1 standard deviation. From the next one to here is 95% of your data. And then from the outer limits, you have 99.7% of your data. Now, if you're wondering why it's not 100%, sometimes there's an outlier, right? Like sometimes in a classroom full of kids, everyone's, within normal height, and all of a sudden someone's 6'5". That outlier would be why this is maybe not 100%. So I wanted to do an example of that so that you have a better idea with real numbers. So if I told you the average test score was 74 with a standard deviation of 6.5. So I'm going to set that up. So I would put my mean in the middle, so 74. And if I went one standard deviation over, I would add this 6.5. So 74 plus 6.5 is 80.5. Another standard deviation over would be 80.5 plus the standard deviation, which would be 87. And this would be 93.5. Now going to the left, I would subtract one standard deviation, so that would give me a score of 67.5, a score of 61, and a score of 54.5. So this is saying that 68% of students scored between here, 67.5 to 80.5. Okay, which would be what, a D plus to a B minus. Then I would say 95% of students scored between 61 and 87. And then finally, I would say, 99% of students scored between 54.5 to 93.5, which is pretty accurate. Most of your students score between an F and an A, right? That's from 54 to 93. So that's how you would read that data and those categories. The book goes over outliers and how that can skew your data, but I'm not just going to copy down what the book says. So we are actually going to move on to 61 point C, because that's where I think you're going to need the most practice. So I'm going to go over quite a few things in 61 point C. 61 point C goes over a stem and leaf, and also a box and whisker plot. So I'm going to go over both so that you're able to do both. So number one, I'm going to give you a long list of data, but I'm going to be nice to you and I'm going to put in order. So let's see here, 55, let's do 60, 60, 65, 69, 69, 71, 71, 73, 76, 78, 80, 83, 85, 87, 92, 92, 94, 95, 96, 96, 96. And we're going to build a stem and leaf plot. So stem and leaf is really simple. So you draw a line down the middle, or label one column as stem and the other as a leaf. And we're going to organize our data by tens. So, and it doesn't matter if you start with high or low. So first, I'm going to calculate my range just in case they ask. 96 is our largest number, minus 55, right, which would give me a range of 41. If they ask for the mode, just as review, that would be the number that occurs most often. There are 3 96s, so that would be the mode. But here's how you do a stem and leaf. So let's say I start with the smallest number. I only have one number in the 50s. So I only list the tens place, not the ones. So I list the tens here, and I list the ones here. I only have a 55. So when I read this is 55. I have several 60s. So I have 60. And then you have to use a comma. I have another 60, so I just put 0. So I would read this as 60 and then another 60. Then I have a 65, and I have two 69s. So instead of writing, this becomes handy when you have a lot of data and you don't want to write it all out. So I would read this as 60, 60, 65, 69, 69. Now the 70s. I have a 71, comma, another 71, a 73, a 76, and a 78. Okay. Then our 80s, right, I have an 80, an 83, an 85, and an 87. So those are gone. 92, 92, 94, 95, and then I have 3 96s. So that is one way you can organize it. You could have also started with the 90s and gone down to the 50s. I don't believe it matters. So that is a stem and leaf plot. Really simple. Now let's go over how to do a box and whisker plot. Now you need 5 pieces. You need your minimum, you need quartile 1, quartile 2, quartile 3, and your maximum. Now Desmos will find all of this for you. Most calculators won't do the quartiles. But quartile 2 is going to be your median. Okay, so whatever your median is, not your mean, whatever your median is, that's quartile 2. So we're going to practice 2 of them. So the first thing you must remember is that your data has to be in numerical order. So I'm going to list my data: 16, 22, 28, 33, 35, whoops, that should be 35, not 25. And I have to have it in numerical order to find the median anyways, but you definitely have to build a box and whisker plot. All right, so looking at this data, I was talking about outliers earlier. An outlier is a piece of data that obviously doesn't fit the rest, and it skews your data because it will either increase or decrease your mean and your median and all that. So in this one, I hope you can see by looking at it that 120 is not only my max, but it is also my outlier. Okay, 16, so I know that 120 is my maximum, and I know that 16 is my minimum because it's the smallest. Now to find a median, start on the outside and you're looking for the middle. Now I have 8 pieces of data, so I'm going to draw a line. This right here would be my median, which is 34, which is also quartile 2. Because whatever our median is, that's our quartile. Sorry, I needed more cafe. All right, now, quartile 1, I'm going to cover up this half of my data, and I line it up with quartile 2. Quartile 1 should be the median of the lower half. So this is the lower half of my data. I'm looking for the middle of this data, and I have 4. So I have to divide my data into equal groups. So if I draw a line there, I have 2 pieces of data in this group and 2 pieces here. So this would be quartile 1, and then I need to calculate it. So 22 plus 28 divided by 2, or think about where the middle would be, but that would be 28 plus 22 is 50 divided by 2, that would be at 25. Okay, now I'm going to cover up the lower half, so I can see, here's my median, And I also have 4 pieces of data here. So if I divided this into 2 equal groups, I'd put a line here. This would be quartile 3, 40 plus 50 divided by 2. That would give me a quartile of 45. So I'm going to use my minimum, quartile 1, quartile 2, quartile 3, and my maximum to do a box and whisker plot. So the first thing I'm going to do is draw a number line, and I have to include all of our data. So I'm going to start with, I'm going to go by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 110, 120. Okay, and so above the number line, don't draw on the number line, I'm going to plot my data. So if this is 20, then 16 would be a little over halfway. So there's my minimum. Then I'm going to quartile 1, here's 20, so 25 would be here. Now do you see how I drew a line above? I'm going to match that here. There should be a line for the numbers that I drew a bar up above. So quartile 2 is at 34. 34 would be halfway between 30 and 40. So there's quartile 2. And then 45. And then my maximum right way over here. So you form a box with the bars, and your whiskers are straight lines out to your, this is your minimum, and this is your maximum. So that is what this would look like, okay? If it helps, I don't know, there's 20, there's 40, 60, 80, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Technically, sorry, this should be 110, which means this over here is 120. So my max is even further out. So let's try one more of those just in case you need the reference. So my data is 3, 7, 7, 8, 9, 12, and 14. Now in this list of data, they're all pretty close, so there's no outlier. So first I can identify, right, 3 is my minimum, 14 is my maximum. Now I'm going to find my quartiles. So I like to find my median by starting on the outside. You always have to find your median first. Outside, and I work my way. 8 is perfectly in the middle. So this is quartile 2 because this is my median. So always start with quartile 2. Once you have quartile 2, I'm going to cover up this and look at the bottom half. Now I have to divide this into an equal, if I cover up that 8, I have to divide this bottom half into 2 equal groups. Well, there's 3 numbers. True, so if I draw a line here, there's quartile 1. Notice now I've got a number, a quartile, a number, a quartile. It's a perfect pattern. So I'm going to repeat that here. I only have 3 numbers, so I'm going to have to make this quartile 3. But now I have a number, a quartile, number, a quartile, number, a quartile, number. So let's draw our number line. It's going to be much smaller. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16. So 14 is my maximum and 3 is my minimum. I should have a quartile at 7, at 8, and at 12. So I drew lines just like I did up here. So the lines form the box, and then there are my whiskers. Hopefully these notes help. For homework on 61, we are going to skip numbers. I just want to confirm because I have the homework right here. 5, 8, 27, 29, and 30. Thank you.